Welcome to the presentation of our papAI time series forecasting module. The first step to start with is the creation of a new project for our time series forecasting. Some configuration are needed during the creation and a description can be provided. Now that the project is created, we can import some dataset or time series data. This can be done from different sources, file in a local storage, a database connection, or even an API. Here, our data is saved on a CSV file. We open the file and a preview of the data is presented. In this case, it's the history of energy consumption and pricing per hour. We have here our time column, pricing column, and some other measurements. Now that our dataset is successfully imported, we can start our project pipeline. We can do some cleaning operation. In this case, the time column is imported as string, so we need to convert it to timestamp type. The operation can detect the best format from the content of the column. Let's run the operation. And the new dataset is added to the flow. If no other cleaning steps are needed, we go directly to the mnlab. We create a new use case of type TS forecasting with the requested information like the frequency, the target, the model type, univariate or multivariate, transformers, and even features. Now that the use case is created, some TS statistic computation are started automatically, as the periodicity and stationary check, the maximum and minimum values of the series, the missing values, and the histogram of target distribution. The second tab is for the time series visualization. Line and bar plots are proposed. We can do aggregation per time features like month, day of the month, day of the week, and all that by selecting an aggregation method like sum, median, average, and so on. Going to the third tab where we can run the autocorrelation test and interpret it. Here we have the seasonal decomposition method that is very used to study the main components of our series, seasonality and trend. Moving now to the forecasting part, in this screen we can create some experiments. A list of forecasting models are proposed and can be used. We will train an ARIMA model, we parameterize our model, we put another one to compare the result of the two models and choose the best one. Let's say profit. In addition to model parameters, we set up the validation set also in this screen. Then we click on Train. The result of our two trained models are here. We can see and compare between them using different metrics. Now let's check our profit results. All metrics are displayed. The real values, backtest sets, prediction are also plotted on the same graph, a scatter plot of prediction against real values, and the error distribution histogram. Our module can also handle the panel case, so we have multiple groups on one series. We can take as an example this flow that was created the same way as the first one, but with more cleaning steps. It's a dataset that contains historical order demands of different project categories on different warehouses, and we are interested in forecasting the future demand month after next. Here we have a visualization of order demand per month on each categories. Going to the mnlab now, a use case is already created and set up to the panel case with warehouse product category as groups. Here are the list of models that we present. They are all deep learning models that gives very good forecasting results for panel cases. 3 of those models have been already trained and their results are already available. Checking for example the result of this one, we can see the forecast performance of each category on each warehouse. If you want to learn more about our time series module or to have a full demo of our papAI platform, feel free to contact us.